Today we're looking at 5.1, rate of change in slope. Our goal for today is to find rates of change from tables and also to find a slope. So first, our vocabulary. The rate of change is the change in y over the change in x. And slope we say is rise over run. Or if you're given two ordered pairs, we do y2 minus y1 over x2 minus x1. So let's look at some examples. If we look at example 1, it says the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So if I look, the way I find the rate of change is I look at the change in x and the change in y from one point to another in my table. So from 260 to 520, I'm going up 260. From 520 to 780, I'm going up 260. From 780 to 1040, I'm going up 260. With my x values, from 1 to 2, I'm going up 1. From 2 to 3, I'm going up 1. From 3 to 4, I'm going up 1. Okay? The rate of change means the change in y over the change in x. Now the triangle represents a delta symbol, and delta means change in. Well, the change in y is 260. It's going up by 260 each time, so that goes on top of our fraction. The time is going up by 1, and that's the x value. So I take 260 divided by 1, which is 260. Now what does the rate of change represent? Well, the change in y is the feet. The change in x is the minutes. So we are increasing 260 feet per 1 minute. So it's 260 feet per minute. So let's look at the second example. The table shows the elevation of a hang glider over time. Is the rate of change in elevation with respect to time constant? What does the rate of change represent? So, if I look at this one, from 260 to 325, we're actually going down 35. So I'm going to use a negative. 325 to 290, we're going down 35. From 290 to 255, we're going down 35. The time, if you notice, is going up by 1 every single time. So my change in y over my change in x is negative 35 over 1. So this means that we're decreasing 35 feet per minute. So this is feet per minute. Now that's rate of change from a table. Let's look at finding slope from a graph. If we're going to try to find slope from a graph, what we need to do is what I call find two pretty points. And pretty points means they cross the grids so that you can tell or that you have integers. So like right here is a pretty point because I can see that it crosses the x-axis at 3 and the y-axis at 3. We hit another pretty point right here because both my x and my y values would be integers. I hit another pretty point right here. So I take two pretty points, so I'll use these two, and I count my rise over my run. For the rise, what that means is you're either going up or down. The run is going right or left. So in this case, to get from this point to this point, I would have to go up 1 and to the right 1, 2, 3, 4. So my rise is a positive 1 because I'm going up. My run is a positive 4, so I'm going to the right. So my slope is 1 over 4. Now over here, my pretty points, see this is a pretty point right here. This is a pretty point. 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 You need to pick two of them. So I'll pick this one and this one. And we're going to do rise over run. So to get from this point to this point, I would have to go down 1 and over 2. Since I'm going down 1, I'm going to use a negative 1 for my rise. My run, since I'm going to the right, it's a positive 2. So my slope is negative 1/2. So that's how you find slope using a graph. Finding slope from 2 points. If you're given two ordered pairs, you use the slope formula. And the slope formula is m equals y2 minus y1 over x2 minus x1. The 1s and 2s represent your ordered pairs. So notice how I have two ordered pairs. So this ordered pair could be my x1, y1. This ordered pair could be my x2, y2. Every single time, it's always y2 minus y1 over x2 minus x1. So like my y2 is negative 2, my y1 is 0, my x2 is 3, my x1 is negative 1. So then I simplify. Negative 2 minus 0 is negative 2. 3 minus negative 1 is 3 plus 1, which is 4. You always want to simplify your fraction. Negative 2 divided by 4 simplifies to negative 1/2. So over here, I'll take this. This is my y2. So 5 minus my y1, so 2, over x2, so my x2 is 1, minus x1, and my x1 is negative 3. So 5 minus 2 is 3. 1 minus negative 3 is plus 3, so 1 plus 3 is 4. 3 over 4 can't be simplified, so that's my answer. So look at 3. Here, remember, this is my x1, y1, my x2, y2. So if I do y2 minus y1, I have 3 minus 3. x2 minus x1 is 4 minus 1. 3 minus 3 is 0. 4 minus 1 is 3. I can simplify this. 0 divided by 3 is 0. Number 4, here's my x1, y1, my x2, y2. So I have 5 minus 2 on top. On the bottom, I have negative 4 minus negative 4. 5 minus 2 is 3. Negative 4 minus negative 4 is actually negative 4 plus 4, which is 0. Now, 3 divided by 0 is not 0. Whenever you have 0 on the bottom, we call this undefined. Now, if you notice from my slopes, I have one with a negative slope, one with a positive slope, one with a slope of 0, and one with the undefined slope. So if we look, lines with positive slopes slant upward from left to right. So they go up. It's like someone going up a hill. A line with a negative slope goes down from left to right. So it goes down the hill. A slope of 0 is a horizontal line. And then an undefined slope is a vertical line. Now this was our lesson on slope. Please go back and fill out the Google form, and I will see you guys tomorrow.